And looks like we are live. Good evening, everyone. Let me know if you can't hear me or there's any issues, as always. So, welcome to the live chat once again. It is Wednesday, March 19th, 2025. And it's getting a little bit more quiet, but we're moving back into an active weather pattern, but not a severe weather pattern. We're going to talk about all that and also some more topics on the CCM. First, though, I just want to let you know, because it's very important breaking news. The Mets are winning 7-0 against the Houston Astros. So it's very important. We'll be doing live break-in baseball updates as we move on through the spring and summer as the Mets go on to take their rightful place in taking over the the National League East, and then the National League, and then deposing and getting rid of the Dodgers, the most overrated team in baseball and also the most overrated player in Ohtani. Now, first things first, book time. I wanted to share this book, Atmospheric Science: an introductory survey by John M. Wallace and Peter V. Hobbs. For those of you who don't know, this is the go-to book that literally every meteorologist has to get, especially when they're heading into college. So if you're looking for a cool gift for that high school senior that's looking for some textbooks, everyone needs this. Everyone has to buy it. It's a little pricey book, but it's well worth it. A lot of great stuff in here. Some basic equations, great charts here on different atmospheric setups, and the way that the atmosphere is set up. The troposphere, very small compared to the thermosphere, which is very large in the atmosphere. So a lot of stuff that you may not even consider, that you never even knew. And the reason why I am sharing this book, which I am going to be using quite a bit for the CCM, which I'll talk about in a moment. So if you are interested in this book, you could definitely find it on Amazon. You could find it on the AMS website, but really it's easy to find it on Amazon. And trust me, it's cheaper on Amazon than it is if you go to buy it on a college campus because A, it might be used, and from the immortal words of a very smart man, you don't want to use a used book because you never know if an idiot actually was highlighting everything. So you want to get a fresh book and you highlight the topics yourself. So this is a great book that I would suggest. Again, it's Atmospheric Science, an introductory survey by John M. Wallace and Peter V. Hobbs. I still use this book to this day when I'm forecasting. If I'm getting stumped, overwhelmed by the model guidance, I want to step back and look at the actual equations and kind of get a refresher. That's really a great tool to use. So definitely check that out. Now, I've been talking about the CCM quite a bit, so I figure, let me see if there it is. Okay. So, what is the CCM? The Certified Consulting Meteorologist Program. I got the CDM, which is the Certified Digital Meteorologist. That was like the first stepping stone for me. Honestly, again, this is probably, just being frank, part of my struggle with imposter syndrome. I didn't think I was good enough to get these certifications, but because of the help of my wife, for example, uh, I decided I was going to go for this, right? So the CDM was the first thing, the Certified Digital Meteorology designation, which is great. And I strongly suggest any young meteorologist looking to get involved in social media and whatnot, I would strongly suggest you getting involved in that. Then you have the Certified Consulting Meteorologist Program. This is for highly established certification that is focused on a lot of meteorologists that work like in the energy field, work with lawyers, provide consulting for major companies, snowplow companies, whatnot. It basically, if you get this certification, it basically sets you on another standard. So, what I want to show, okay, as an illustration for those of you young meteorologists out there, the reason why I'm showing this is that I started out with after my first job in meteorology. I lost that job. I decided to move out and whatnot. And I was completely lost, right? Starting out. And I built this all from scratch. What I want to show you is that no matter what, especially after what's going on with NOAA and all the confusion going on there, no matter what situation you're in at the current time, there's always a way up. There's always a way to move yourself up. And I would strongly suggest getting involved in the American Meteorological Society to take advantage of those opportunities and learn how you can grow them and push yourself. And the CCM organization board is really starting to recognize those who are kind of out on their own, is starting to do consulting on their own as another avenue rather than having to go work for a major company like a AccuWeather or whatnot. So this is something I'm going to be working on. I can't share the test questions. That's a big no-no, obviously. But I will be working on this over the next 90 days to earn it. And I'll give you updates on the books I'm using, what I am trying to test, and we'll go from there. Now, let's talk about the weather, because I know that's what everyone is here for. So we are definitely seeing changes in the atmosphere, a lot of the forcing mechanisms. And as you know, our La Nina has crashed and burned. We don't have an El Nino yet, but we certainly are moving towards a warm neutral state. This area is probably the coldest in all of the Pacific, and it is gradually moderating in Nino 3.4. Nino 3, should I say Nino 4 is slightly cold. Nino 3.4 is slightly above normal. And Nino 3 and Nino 1 plus 2 are now above normal. So we're moving towards that level, that environment where we have a warm neutral state in place overall. And with that being the case, it starts to influence the subtropical jet stream. And here's a great, of course, it always goes off. Okay, so here's a great example of what I was talking about here. With the enhancement that we're starting to see, and let's see if I can get my line here. Okay, you see this right here? This jet streak is the development is being enhanced by that warm pool of water that's starting to grow. And the reason why that's really important is that as this jet streak intensifies and sends short waves towards North America, it's going to enhance our subtropical jet stream over North America and increase the potential for pretty vigorous low pressure systems in the plains lifting up towards the Great Lakes and the Ohio River Valley and Tennessee River Valley. So this is the first step to get you towards, seeing more severe weather. I think that the plains in the Mississippi River Valley and the Tennessee River Valley, upper Midwest, all those areas throughout this spring are in for a heck of a severe weather season, unfortunately. So if you know people who are chasers or you're a chaser yourself, first of all, use extreme caution. Be safe out there, okay? No picture or data is worth getting yourself into a bad situation, and no media exposure is worth that either. But it is going to be a very active season when I start seeing this. Okay, and the reason why is that in an El Nino you start to get a little bit of a, let's say, a limitation in the polar jet stream interaction, right? But when you have a warm neutral state, you kind of get both jet streams kind of battling with each other a little bit more. And that is when I tend to see a lot of severe weather starting to break out. Now, the other issue that we have playing around here is what's going on with our polar vortex. I wanted to show a different image. This is from the GFS. It's a really cool display from stratoobserve.com. It basically gives you a structural analysis of what the polar vortex actually looks like. So this is all levels of the atmosphere. And when you see this, let's see if I can zoom in on this. You can see the lower portions of the polar vortex is really getting warped and ripped apart. The upper portions are getting warped and ripped apart just as much. In fact, as we move on through the 15 days, it pretty much dissipates. So what's happening here is that your whole polar vortex structure is collapsing and you're losing your influence on the troposphere and the 500 millibar pattern. but it kind of creates this echo. Now, this echo clearly has a stronger influence towards Siberia and Asia. But because of that evolution, it opens up the potential for a pseudo negative NAO pattern. But you want to be careful and jump to conclusions on what that means, because a lot of people, when they think negative NAO, they think like winter time conditions. Different weather pattern now, different season. So clearly, there is a ton of support in the European 46-day forecast for a sustained long-term negative NAO pattern. Okay. So, most likely, when we get a little bit closer, more in the synoptic range, we're talking about 5 to 10 days out. This is probably a little bit more volatile, maybe heading towards more neutral, maybe some positive days, negative days. For the most part, is the overall theme. So, I don't think it's going to remain negative all the way through, but the predominant phase is going to be negative. That's how you typically want to read this. Again, you never take this stuff verbatim. So most likely, instead of it, being down here the whole time, it's more likely kind of like here, 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 and then here. And so there's your general theme, right? So that's what we're most likely going to experience rather than just continuously sustained, because it's really hard to get a pattern constantly locked in for over a month, but most likely you'll get those waves. But what does that look like in the 500 millibar pattern? Well, what it looks like is a displaced negative NAO. Notice the position of this. And let me zoom in on this here. So this is not your traditional negative NAO that you would see, a lot of people talk about in the winter. So you have your lobe here, and then you have your ridge up here. Okay, so let me go right there. Now, this is more of an east-based negative NAO. And what that means is that your storm tracks can cut up this way and then get redeveloped. So there, and then redevelops and head out towards the Gulf of Maine. And when you have that type of environment, it opens up the potential for a lot of backdoor cold fronts. So your warm air surging northward at 850 millibars, but this environment down here, in fact, let me use a different color. So we'll use blue here. So that sends your cold air at the surface down over the warm air. So what you end up with really is a lot of cloudy days, a lot of showers, and a stable air mass trying to fight against the warm air transport. So that's what we see in the synoptic realm. Okay, right now we're in the synoptic realm. In the climate realm, actually, first, let me show you the 850 millibar temperatures, just to point out that we're seeing a lot of your cold air block northward. You get what looks like a polar influence, but really it's more from the Canadian Maritimes at the lower levels of the atmosphere, like around 9 to 25 millibars. So this is a signal that, hey, we're going to see a lot of back and forth with these air masses. And this looks awfully warm, right? Use caution. With this signal, don't be surprised at 900 millibars, 1000 millibars. You get that maritime air mass coming in. And I would not be surprised to start April if we end up with a situation where Long Island, New York City, maybe northeastern New Jersey are stuck in the 50s, and Philadelphia is 75 degrees. And you have a powerful 20-degree gradient. It's cloudy with showers and mist and fog around Long Island, and Philadelphia is sunny with warm temperatures and perfect conditions for baseball. I would not be surprised of that at all. Meanwhile, 850 millibars, it looks like everyone should be in the 60s and 70s. So that's what we're seeing here synoptically. Climatologically speaking, what I'm seeing here play out, first of all, look out to the west in this entire pattern all the way into May. Overall, you don't see any strong ridges. You get basically this zonal pattern here. Let me fix that here. So you get this overall zonal pattern, if I could draw it properly. Sorry about that. There we go, finally. Okay, so that zonal pattern taking place here. So this tells me, first of all, We got a lot of Pacific air masses. You might get a nice little storm evolution take shape here that heads out, but you're not going to see a deep trough dominating the western United States. You're going to get more of a zonal, fast moving pattern. So, most likely, watch out for very warm air masses here shooting across the plains. That in itself could spark your severe weather outbreaks, um, especially around the plains, especially right around this area right here. Okay. This is where I'm thinking that we could see a lot of severe weather breaking out. But what about for us? Well, this signal back here, make sure, yeah, there we go. Perfect. Okay, this signal back here is your negative NAO pseudo signal that we saw on the camera on the map here on the chart, should I say? Now, that type of signal sends maritime air mass southward. Let me fix that here. So a little bit like this, right? So what typically happens in this type of scenario is you get a lot of warm fronts just kind of stuck and they start moving very slowly. And in this signal, what this could lead to is a lot of good rainfall events. Not severe weather, but a day of steady light to moderate rain, drizzle, a lot of mist, and like a heavy downpour here and there. And that is really important. If this pans out, if this scenario sets up, you can end up with above normal rainfall here and helping to really break our drought. Now, as I've said for several months now, we do not want wave after wave of 2 to 3 inch type rainfall events because it screws with your topsoil and the water doesn't get into the water table, which is what we need. Good coffee. What we need is a lot of light to moderate rainfall events. And this type of pattern that we're seeing here, that actually sets up a pretty good environment for us to get that. So that's certainly some good news in that respect if this actually pans out. So the start of spring has been above normal. We've had a lot of above normal temperatures. March will likely end up with above normal anomalies. April looks like it's cool. May, I think it starts cool, but then shifts warm. Why? Because typically what happens in May is that this signal that keeps on showing up gets displaced even further north, more towards, say, to the north of the Canadian Maritimes, more north of Newfoundland, and more towards just to the south of Greenland, which is typical of the time of year. And what happens is that your ridge gets a little bit stronger over the Western Atlantic and you start to end up with warmer weather patterns. Okay. So I think that May probably ends up above normal. And then the combination of all spring ends up with above normal temperatures. But the key story here is I think we're going to see a lot more rainfall moving forward, which is something that we seriously need. And again, keep on loading up all the questions, guys. I will be answering all your questions tonight. First, of course, starting off with the live chat and then visiting and checking out seeing social media after I get done with my spiel that I set up. So, what about the next 90 hours? Any type of severe weather? No, but we do have a good potential for some rain. Now, right now, we have that easterly wind that is playing havoc here. Temperatures, aren't too bad for this time of year, basically 40s and 50s. We got some 60s back here towards southeastern Pennsylvania. This easterly wind, anytime that we see this easterly wind and anyone's talking about severe weather, ignore them. Okay, they don't understand the northern Atlantic because this wind transports a maritime air mass, and we're going to take a look at a skew T in a moment, and I'll show you exactly what I mean. But this type of transport sets up a very stable air mass at the lower portions of the atmosphere, and stable air masses are not supportive of thunderstorms in general, unless they're elevated, and certainly not severe thunderstorms. So obviously right now it's pretty quiet. Now you're seeing some of this signal here in precipitation, but this isn't reaching the ground. What it really is just a lot of low and mid-level clouds. Take a look at this. This is really cool. Okay, and you see the lower clouds coming in. That's your easterly wind. That's your stable air mass. That's your marine air mass driving in towards the coast. Let me see. We use a different color here. I think this might be green. Okay, so there's that right here. Okay, well, I'm making an attempt. Okay, so oh well, I tried. So we'll try blue. How's that? There we go. Okay, that shows up. So there is. Let me fix that again. So here is your maritime air mass coming in via that easterly wind. So you can literally see on the visible satellite picture the denser, colder air being transported and pushing towards the coast on that easterly wind. Meanwhile, aloft, all these clouds here are being driven by warm air transport at 850 millibars. So, what I want to show you this evening is literally that setup that we're going to be looking at for much of April showing up tonight in kind of a microcosm. Okay, so what you're going to see a lot in during the fall, during the spring, during especially during April, is you're going to get a lot of these mid-level clouds that are showing up here, coming in from the 850 millibar jet with the warm air transport, and then this is your maritime air mass transport coming in towards the coast, and you'll be able to pick that out by all the low clouds. So and eventually fog, and so that is what is heading towards our neck of the woods. I thought that this was really cool to illustrate what we're seeing here as far as the evolution of our pattern. On the infrared satellite picture, it plays out even more nicely. I mean, look, this is beautiful. There's your upper level low, very impressive, and your severe weather outbreak as a result. This enhancement of the clouds. This is a perfect example of mid-level frontogenesis. You're getting that clash between the warm air surging northward in the mid-levels, the cold air coming in from that easterly wind at the surface. And it doesn't need to be a huge air mass. It just has to be, from the surface up to 950 millibars. Very small layer in the atmosphere, setting up this gradient, and eventually it's going to set up showers. But the lifting just isn't strong enough just yet to support those showers. But by tomorrow evening at this time, we'll have plenty of showers with this clash becoming enhanced by the falling 500 millibar heights by this upper level low heading up towards the St. Lawrence River Valley. And you can see that again even more nicely on the water vapor satellite picture. Look at all these upper level lows. Absolutely beautiful. I was saying to a friend earlier, the one thing that made me fall in love with meteorology, that made me say I have to do this for a living, was when I was roughly 8 years old, and Jim Cantori was live on the Weather Channel, and he used the water vapor for the first time, and it just made everything click, on how to view the atmosphere. And you can just see all the different moving parts at all different levels of the atmosphere. There's your 500 millibar low, your 850 millibar low. There is your thermal gradient, and there's your frontogenesis at the mid levels, setting up here all the different moving parts here. So very interesting. I just love seeing it. And then at 250 millibars, this ridge right here that's showing up at 250 millibars, it creates what we call subsidence. So when you have this setup, this is why, even though we're seeing these low clouds and you're seeing this lifting, this negates that over us and just keeps us dry, which is cloudy conditions. So again, this is the cool part about looking at different layers of the atmosphere and kind of getting an idea of how each layer. And the thing that's difficult about meteorology, and even more so when we're talking about winter storms, is that there's never a hard rule. Okay. Each environment has different mixes in terms of influence. And what you have to do is take a look at those influences and try to weigh and see which one has the greatest influence on your weather pattern. So over the next 90 hours, we're going to be pretty busy. We have a lot of short waves marching their way through. This first one, notice the enhancement here. This is going to open up an enhancement at 850 millibars and allow a nice 850 millibar load triding to form. And because of that, we're going to get cyclogenesis right over us. That's why we're going to see an enhancement of rainfall. There was some thought that maybe we could see snow mixed in on this, but I wasn't buying it, and it looks like that was a good idea. Now, that lifting here is going to enhance your precipitable water value. So the reason why we see an enhancement is that the evolution of this 850 millibar low is going to lift all available moisture from the surface up into the mid levels. And so that's why you see this enhancement here showing up. So that's why we're going to see that growth in the precipitation shield because of that lifting and that process. And so what you end up with is this setup here where you get this rainfall growing and that low pressure system taking shape. Now, you might see a snowflake in northern Connecticut, but that's about it. If you're looking for snow out of this, you're going to head towards the Green and White Mountains. Now, why aren't we seeing any severe weather out of this? Even though I know we aren't really expecting any, but this is a great teaching moment because it gives you a chance to take a look at the SKU-T. This is from the NAM model guide, so you want to use a mesoscale model. You could use the European or GFS for just to kind of get a ballpark idea, but once you get under 60 hours, you really want to use the NAM or the HRR. NAM's the best in this time range. The HRR is good if you're under 18 hours, and it looks like it's matching up pretty well with the observations. Excuse me. Now, see this signal here? Anytime you see this signal on a SKU-T, no severe weather. You might get elevated thunderstorms or elevated instability, but in terms of severe thunderstorms, this right here is a signal of a very stable air mass, okay? So whenever your line goes this way, it's going warmer. As you're going aloft, then that means that the parcel in the atmosphere can't rise, right? So the parcel in the atmosphere, it ends up being colder than the surrounding air mass, and so it sinks. When a parcel, or in this case water vapor, is warmer than the surrounding environment, so this is getting colder as you move aloft, then it's able to rise higher in the atmosphere. And the higher it rises, the more the cloud grows. The higher the cloud top, the stronger the lifting. So this supports growing cloud tops, but this signal here limits that, okay? It prevents the water vapor from rising. So in this case, you need that synoptic lifting. That's what we talk about, PVA and all that stuff. So that's why it's very important to understand the SKU-T and not to jump to conclusions in terms of potential for severe weather and thunderstorms and whatnot. You want to really study the SKU-T and take a look at the environment you're working with. So in this case, this is a wet, raw signal, not severe. So, and not that anyone was really forecasting severe, but I just kind of want to make that point because it's so obvious. It's good to use as an example, just so people understand what we're looking for. We're looking for the exact opposite of what that signal is showing. Beyond that, again, we get a nice little high pressure system, nice little ridge axis passing through Friday night into Saturday morning. So Saturday morning looks to be okay. Then we get another weak trough on Saturday afternoon. Notice how weak and diffuse it is. And then at 850 millibars is even less impressive. So what this signal usually tells me is that, well, we're not going to see much lifting. And look how weak this is. You're lucky to break a half an inch in terms of precipitable water value. So anything that forms is producing less than a quarter of an inch. And so overall, the weekend doesn't look too bad, really. Friday afternoon looks pretty good. Saturday morning looks good. Saturday afternoon, a few passing showers, but not a washout. And then as we head towards Sunday, well, it gets even better. It's a little chilly out there, but overall, not too bad of a weekend. Dry conditions are expected by the time we get to Sunday afternoon. So plenty of sunshine until we get our next low pressure system coming through on Monday. More rainfall, maybe about a quarter of an inch. Again, not a huge amount, but enough to make a little small dent in our drought conditions. There's another low pressure system, another low pressure system. Notice as we move on through our 15-day period, not a lot of heavy rainfall events, but a lot of light to moderate events marching their way through. So that is my breakdown of the weather pattern that we're going to be seeing. Now it is time to answer your questions and see what we have here. Of course, we're going to start off with the premium chat as premium members get all their questions asked, and then we'll check out the social media world, see if there's any good questions out there. You guys normally don't disappoint, so I'm always looking forward to answering those questions. But first, a little bit of coffee. Good coffee. All right. So let's see what we got here. As always, Card is starting off the band here with plenty of questions, always good ones. Wonder how many of the usual suspects are posting a GFS run from 18Z today and touting snowstorms 300 hours plus, which are utterly impossible according to basic physics. Okay, so my opinion on the GFS is that if there's one thing that Doge should get rid of, it is the GFS. For the love of God, leave the meteorologists alone and just destroy and cancel and cut and get rid of the GFS because I am tired of that model just creating a whole bunch of havoc. That's just my opinion. Uh, Physically speaking, the GFS just doesn't make any sense, which is why I didn't even bother displaying it here. And of course, no surprise, it's the 18Z guidance. I don't understand why the physics is off in that model so much. I mean, for God's sakes, just copy and paste the European and just get on with it. It's just ridiculous at this point, and it's sad. Just because, again, just because you have a negative NAO pattern, which I'm not disagreeing with, doesn't mean you automatically end up with snow unless you're in the green and white mountains and elevations above 2,000 feet. Then sure, game on. Um, but I don't know. I just scratch my head. And again, I come from the world of what we used to call Murphicanes, the MRF model guys back in around 1998, 2000, where you'd get like a forecast up to about 5 days, and all of a sudden it spins off a hurricane out of nowhere in December. So I'm kind of used to that type of guidance. You just gotta move on. Uh, Much needed rain this week. You were right up on the premium. Look for April was very encouraging at providing us some regular rain that will hopefully cut into the drought conditions. Yeah, for premium members, I wrote a long range, so it's kind of like a preview of my April forecast that I'll have out next week. But just the data was very interesting. We'll see if it holds. But when you have a neutral PNA and a negative NAO in the spring, that usually leads to I don't want to say heavy rain, but damp. Okay, let's say a damp weather pattern for the region with the potential for some good rainfall events here and there, but overall a lot of easterly flow. So that certainly is going to be a factor moving forward. Tom Moore's piece last Friday. Tom Moore is an outstanding meteorologist and historian who I am very privileged to be able to post his content every week. So check it out every Friday at 9 a.m. It always shows up on the public page. So definitely check that out. And of course, I share it on social media, totally free. Um, Tom Moore's piece last Friday of the 1994 Palm Sunday tornadoes was outstanding. It always is. Always has amazing articles about meteorological history, and I would strongly suggest checking it out. Overall, it looks like the very cold spots, for most part, got warmer, and the very warm spots got cooler, other than a couple of spots. I think we're talking about Enso. Yes, we're seeing basically the collapse of any of these cold anomalies, especially at the subsurface. It really is fading away. And really, honestly, I can't really call this thing a La Nina. It You had barely La Nina conditions for maybe 8 weeks. And typically, in order to really measure an ENSO event, you need 5, I guess, quarterly periods to really support that designation, and it just didn't reach it. So when the ONI doesn't come anywhere near support for it, that's when I'm just not buying into it. Christopher Stitt, do you see the stripe of weather that appears to move into the area impacting travel from Cleveland area to northern New Jersey over the next couple of days? Oh, you mean the front? I mean, yeah. I mean, we definitely going to see showers tomorrow evening. Not anything severe. Maybe to the west of Cleveland, but around New Jersey and Pennsylvania, we're just looking at a lot of showers. Nothing that is all that impressive. Nothing that would prevent you from traveling. I'll put it that way. Aaron asks, and any thoughts on the potential for overrunning events Sunday night with some light snow over the interior? No, no, I don't buy it. Not for Sunday. Let's see here. Let me go back and explain. Okay, so in this environment, your warm air transport is very strong. Okay. Um, if you're going to see anything, I would say maybe New England, but I really don't like the evolution that we're seeing. Let me show you here. Now, I know what people are looking at with the GFS. I would say, look, burn the GFS, ignore the GFS, just delete the GFS from your use. Take it, and I want you to throw it into a volcano. Okay? Put it into a nitroglycerin plant and blow it up. Okay? Just stop using it. I've stopped using it at this point. I use the European, sometimes I look at the UK Met, NAM, the HRR, European ensembles, European AI, but the GFS, I'm done with it. I'm done. It's like it's like an ex that keeps on promising that they're going to be better and they just get worse. There's just no point. It's an abusive relationship that causes people to post ridiculous nonsense. So don't use the GFS. What I would say is that in this solution here, Green and White Mountains. That's pretty much it. The warm air transport with this event on Sunday night is way too strong. And you're getting a lot of easterly winds setting up out ahead of this. Let's see here. Okay, let me pull up the low level winds here. Give me a second. And we will go and pull up those winds. Where are they? There they are. Okay, so we'll go to Sunday. Here we are, Sunday. Okay, so there we are. Perfect. So I had this way too strong southerly to southeasterly wind all the way up into the interior. This is a warm wind. And if you want to pull up regular European and the 850 millibar jet, I might have to zoom out for that. Yeah. So let's zoom out East Coast. There it is. And then here is Monday. Yeah, very strong. So you could take it even further. Let's take a look at 925 millibar temperatures for that time period. And you might say to yourself, hey, Steve, doesn't this mean that you could see frozen precipitation? Remember the time of year. So this environment equals a cold rain. In January, you might be saying, hey, we got to watch out for sleet and freezing rain. In late March and April, this is just a cold rain. Up here is your frozen precipitation potential. Even in the evening, even at night, it's a different environment, different game. So no, I don't see anything that really stands out. And I do say once again, just burn the GFS, burn it and put it out of its misery. Always thought the warm season negative NAOs meant backdoor cold fronts. Yeah, for the most part, they generally do for the northern mid Atlantic and for New England. I say northern mid Atlantic because southern mid Atlantic it's a lot harder to pull that off. Zonal pattern all the way through the summer with no big heat ridges in the east is perfectly fine with me. I can't rule out a ridge or two popping, but I think we're going to be dealing with a very progressive weather pattern overall. When do you anticipate putting out your tropical forecast? Probably May, mid May. That typically works well for me. I don't like to jump too far ahead, especially with the evolution of the El Nino Southern Oscillation. I think that it's good just to wait a little bit. It worked out really well. Last year's forecast, I was right within a storm. So actually, I was nearly at 100% in the forecast. So we'll see if it works out again. What are the word temperatures off New Jersey shore, and also what are the current ground temperatures? Oh man, I wish. Let's see if I can find that data. That might be a little bit trickier to pull off. Give me a minute. Let's see here. Ground temperatures. I think I got that around here somewhere. Pretty sure I did. Here we are. Ground temperatures overall are in the upper 40s to lower 50s. I don't have a current source, unfortunately. The source I have on the sea surface temperatures is a little bit old. It's going back to uh, late February, which I think is a little bit too dated, but most likely in the 40s and 50s this time of year, typically. Blue, will the warm, moist air over the maritime air create drizzle events when we get light drizzle, which doesn't even show up on the radar? Yeah, that's definitely going to be a theme moving forward. When they are not sending Jim Cantore all over the place to be an on site reporter, he is an excellent meteorologist. Yeah, and you got to love his passion. Won't throw the GFS into a volcano, anger the volcano gods. Well, that may be true. Or bring Godzilla back out. Let's see what we got in social media land here. Um, does the GFS model algorithms over amplify cold air? They always show snow for marginal cold events. It definitely does have a cold bias. That is definitely true. Um, Part of the issue with the GFS is that it tends to over amplify convective development, which creates lifting that really isn't there, which creates a colder environment overall because it creates a stronger gradient, thermal gradient, and creates all sorts of havoc. So I think that's part of the problem. It just doesn't handle, well, I mean, really, I'm trying to think. It really doesn't handle upper level wind components very well. It produces strange 500 millibar anomalies. Um, because of the convective feedback error, it creates a lot of bullseyes with this PVA. I just don't bother with it. Let's see here. Book for $30 off. Only $45 on Amazon. Let me make sure I got all of the latest top chat. For some reason, YouTube is being a little slow. Okay, now I fixed it. Okay, so um, it would be nice if the 12 euro was right in its 10 to 15 day projections. I never trust any model in being right completely in the 10 to 15 day. It matters how you use the model, okay? So what you want to do with a model projection 10 to 15 days out is just look at the overall theme, not the results. Okay, because those will change and switch left and right. In the spring, easily even the best model will have a 10 to 15 degree thermal gradient swing from the 60s to the 40s back to the 60s again, depending on the position of a warm front boundary. So what you want to do is look at the overall theme, which is like, okay, we're going to have front boundary hanging around, a lot of low clouds, variable temperatures. That's how you want to handle that. Book is $30 off, only at $45 on Amazon. Yeah. I'm sure the book has a ton of math. Yep. But is it somewhat understandable for someone who doesn't know math yet? Um, there's a lot of good stuff in here that isn't mathematical based, But you want to get used to, especially if you want to get into this industry, you want to get used to at least looking at the equations. You don't have to solve them. I mean, there's college students that struggle solving them. But what you want to do is kind of get used to looking at the equations. And it does a great job of explaining what the equations mean in terms of the atmospheric connection. So even at an early age, even like as a teenager, I started reading this and starting to go over it. The equations looked really funky to me. I really didn't understand it, but I started to understand at least what the connection was. And when you start understanding that connection, once you start doing the equations and start working them, there's going to be a long period where you're just utterly confused and frustrated. And then one day it just clicks. And that one day could be 3 weeks into the semester. It could be your final. For some people, it is. And it's a struggle. But the more you get used to reading the equations and trying to connect them to how it works in the atmosphere and what it's trying to illustrate, um, the sooner you'll get that click in. So I would say it definitely has a lot of great stuff in there that isn't equation based, but the sooner you start getting used to reading those equations, the better you'll be. Okay, the faster you'll get that aha moment. Let's see here. Will the rain for Thursday evening be nearly as heavy like on Sunday? No, no, it won't be. We'll have a moderate downpour, but it won't be anything like we saw last Sunday. Um, we are in the process. Okay, as far as the QBO, that's a great question. Are we transitioning out of the westerly QBO? Yes, we're in that process right now. We've been in it for a couple of months. It's usually a slow process. Um, you won't see a major impact on the 500 millibar pattern until we get to our easterly QBO in the fall. That's when it'll start to stand out once again. With all the rain that we have received and our forecast has received, do you think that the surface layer is close to being saturated to the point that will be favorable for thunderstorm development? Not yet. There's a potential it will be, but not yet. I can't say that yet. Although we've certainly seen some marked improvements. Anything on Facebook or X? Oh, okay. Fun. See what we got. Oh, Jesus. All right. Let's see here. Let's see. Congratulations for your CCM certification. Well, I haven't gotten it yet, David. I'm working on it right now. Um, let's see. Let's see. Totally agree with the severe threat for the Dixie. For chasers, don't chase alone. Yep. Let's see here. Easterly winds kills severe weather, pretty much, and snowstorms for that matter. Biggest thing we see in QLCs are, and any tornadoes are usually the QLC's situation. Live shear when the maritime air doesn't mix. That is true. And hey, Jeffrey Lamb is watching right now. Hey, Jeffrey, how you doing? The one thing I will say about severe weather and with chasing is that the good ones know how to stay safe. The bad ones are in it for the publicity, and you could tell the difference between the two. Okay, and it's interesting to see. There's some laws that are being passed in Oklahoma, of all places, that is trying to regulate that. Now, there's some suggestion that maybe a news station's behind this regulation, but I do think that there needs to be, at the very least, a little policing within the meteorological community to make sure that we aren't putting people in an unsafe scenario. And look, there's a lot of people that storm chase and make a lot of money off of it. God bless you. Good luck. But we need to be aware of being safe out there. Let's see. I still say we should throw the GFS out. I am so fed up with it. I really, really am. I'm sorry. I'm just done with it. Every time. It's the bane of, huh? No, I mean, honestly, here's the thing with the GFS, right? if I'm every day I wake up and I look at the GFS, not for model analysis, but to see what type of crazy, insane posts someone is going to make and copy and put out a snow map on. Because I guarantee you, 99% of the time, it's coming right from the GFS. Never fails. Let's see, I wouldn't be surprised by May, we got our first hurricane showing up on the GFS. And I wouldn't be surprised if you end up with a solution with snow and a hurricane showing up 15 days out on the GFS. And someone's going to post it. And I'm just going to shrug my shoulders and say, yep, GFS, GFSing. I'm just so fed up with it. Fix it. Like I said, if Dodge wants to get rid of something and save some money, get rid of the GFS. Keep the meteorologist, get rid of the GFS, and ask for the European guidance to loan it in. And there we go. And then we're done. What? Doge, I don't know, whatever the hell they want to call it. A dog? It's named after a dog. This is how much I know. Look, the bottom line is this, okay? If you want to save money and save what little hair is left on my head, get rid of the GFS. And we could do a whole ceremony where we destroy the computer, we break it in half, we blow it up, okay? Whatever you got to do. But I am advocating, if you want to save money, get rid of the GFS. Heck, at this point, I'd rather have no gaps. I'd rather have the no gaps model from the Navy than the GFS at this point. It's just ridiculous. Let's see here. GFS isn't always used to put out fancy snow maps. In summer, it gets used to post phantom major hurricanes. Absolutely. Like I said, you know what? The GFS is good for? Movie plots for the Sci-Fi Channel. There we go. It is perfect. I'm waiting for it to start to spin the wheel. Yeah, they'll use the GFS and they'll say, "Look, it's a major hurricane that takes over the entire East Coast. Let's use that as a Sci-Fi Channel movie." There we go. That's why the GFS is still being used because the Sci-Fi Channel needs to make Sharknado 10. That's what it is. That's channel. I swear have a wheel that they spin with plot points. It's the same thing. Exactly. It's the weather version of the Hallmark Channel. It just produces ridiculous crap every day. And some days you get lucky and you get Sharknado. That's what it is. That's what it is at this point. It's mind-numbingly stupid to deal with. And I'm just done with it. And by the way, even if they add AI, it'll be the worst AI. I guarantee it. It's going to be the type of AI that doesn't know how to add. That's the type of AI that will come out of the GFS. I guarantee it. So that is my bottom line. If you want to get me an early birthday gift, because my birthday is in August, get rid of the GFS. There we go. Because at the very least, it will save me time. Let's see. Do we have any other questions shooting out here? Let's see. Let me check the dashboard. That looks good. Fortunately, it looks like. Let's see. What do we got here? Jeff here. All right. What do we got here? It's still running on the TI 99 computer it was coded on. That doesn't surprise me. Oh my God. It might be on an Atari. That's yeah, ColecoVision. There we go. Yes. The GFS is run on ColecoVision. I'd love it. Absolutely, I'd love it. That would explain a lot because if you're telling me that it's on a supercomputer, someone really screwed up. Oh my God. We could do better. Look, we can do better. I know we can do better. We have a lot of smart modelers out there. For God's sakes, if you want to improve weather forecasting in the United States, just take whatever the European model guidance did, copy paste it, put it in there, get better observations, right? Improve the observation network. You want to do it at the state level and federal level, and there we go. That's all you need to do. But first thing you have to do is put a shotgun to the GFS. Please put it out of its misery. It's done. I think that's all we have in terms of questions. I've already had my rant on the GFS, which I'll probably have that quite a bit moving forward, as always. So yeah, and YouTube is being glitchy too. If for some reason it's making it difficult to. Well, Facebook's always a pain in the butt. Facebook, like that. Facebook is the social media version of the GFS. So there we go. See, it all ties in. Let's see here. Next Terminator movie, Skynet attacks because it gets sick of seeing the GFS 300-hour snow map. That would be hilarious. Oh my god, that'd be a movie I'd watch. I haven't watched the Terminator movies in quite after Terminator 2 because then it just got ridiculous. Yeah. Oh god, why? No, no, I was done after Terminator 2, but that definitely would be a movie I'd definitely watch. So I think that we made it in through tonight. That pretty much answers everything. We had some fun. We got some Mets baseball. And by the way, they won 8-2. Peterson looks great this spring. 0.57 ERA, 2-1, getting ready to take over the National League. You heard it here first. New York Mets taking over the NL East, taking over the National League. They will humiliate the Dodgers, and then it'll be so bad that all the Japanese pitchers that are pitching for the Dodgers will want to go back to Japan. That's what's going to happen because Mr. Met is going to come over and take over. That is the prediction for baseball this year. That's all it needs to be said. I got no hate against the Dodgers and the Phillies. Look, if you get rid of the mascot who stole my popcorn, then it's fine. Get to the playoffs. We'll see you there. That's pretty much all I have for tonight. Thank you, as always, for joining, for watching, for asking all these questions. As always, I really appreciate it. And as always, stay safe out there.